Hello and welcome back. In this video we're going to take a quick look at truth tables, which are a convenient way for us to inspect the possible values associated with Boolean expressions. Each Boolean variable can have only two possible values, true or false. So with truth tables we can look at more complex combinations of Booleans and the operators that can work upon them. So here we're inspecting a combination of only two Boolean variables, a and b, and we can write out the full set of possible values for them as follows in a table. A and b can be false false, false true, true false, and true true. And you might prefer writing these out using zeros and ones, so 0 0 0 1, 1 0 1 1, and that's counting up in binary from 0 to 3. So having done that, we can then look at our combination of these variables. So a or b is in a parenthesis for not a or b. Okay, so we'll do a or b first. So false false, well obviously a false or false is false, false or true is true, true and false is true, and true is true. So not A or B, well that's easy to mechanically figure out, it's just the opposite of what is in A or B. So we can just go along bit by bit, acting like a machine if you like, to calculate the possible values for this. So not A or B is just the opposite of what we see in this column, so it's true, and then false, false, false. So we've calculated out the possible values associated with not A or B, given the possible values associated with A or B. We'll do this once more on the next slide. And what we're going to do as a result is prove one of De Morgan's two rules. We'll see that as we go. So, not A, given the possible values. So we're calculating out here not A and not B. The possible values for A and B are 0 0 0 1, 1 0 1 1, or false false, false true, true false, true true. So not A, we're just going to go down and do the opposite of whatever is in the A column. So not A is true, true, false, and false. And not B is whatever we see in this column, so that's true, false, true, and false. And then not A and not B is just this and this. Obviously not A, there's the column containing not A, and there's not B, there's the column containing not B. So not A and not B, well, true and true is true. True and false is false. False and true is false. And false is false. Okay. So now we've got a column showing not A and not B, which gives true, false, false, false. And on the previous slide, we had not A or B, which gives true, false, false, false. So if we flip between these slides, we'll see that this final column, not A and not B, and not A or B, is producing the output true, false, 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 and true, false, false, false. So we've just proven the first of De Morgan's rules, which is that not A and not B is logically equivalent to not A or B. So truth tables are a handy little tool that we can use to closely inspect and think precisely about the possible values and outcomes of our Boolean expressions. I've done one of De Morgan's rules here, you can do the other one in your own time. Thanks.